Hello everyone, my name is Minwoo Kang and today I'll be presenting my research, Real-Time Traffic Rerouting Strategies for Mitigating Pluvial Flash Flood Disruptions. But to begin with, we gotta know what problem we're tackling, and in this case, it's flash flood. So what is a flash flood? A flash flood is a sudden intense flooding event caused by heavy rainfall, often overwhelming drainage system. This leads to severe traffic delays. For example, in New York City, experienced a severe flash flood in August 2024. The problem isn't about cars sinking from flash flood, but rather the real problem is the fact that this consistent traffic jam because of flash flood ultimately leads to major productivity declines in many cities. So why is this problem of traffic delay happening? The root of the problem lies in the current traffic systems. The current system relies on static, preset routes that cannot adapt to real-time disruptions. The result is clear. The increases travel time, inefficiency, heightened safety risks, and leads to significant economic damages to cities. So now we know the problem, I'll proudly represent our solution, the Dynamic Traffic Assignment Model, quote-unquote the DTA model. Let's simply go over what the DTA model does. The DTA model is designed to optimize traffic by assigning different routes dynamically, avoiding flooded areas. This allows the model to adjust congestions and respond effectively to unexpected disruptions, making the delay time significantly reduce. Now let me explain how the DTA model works. There are three components you need to know, and the first one is a network structure. The network is essentially a digital map of a city. Each intersection is a node, and the roads connecting them are called links. These links have specific characters such as their length, speed, and capacity. Now we understand the network structure. Let's talk about how we calculate travel times on these roads, especially the traffic increases. The BPR function is the one. This is a formula that calculates how much longer it takes to travel on roads as it becomes more congested. Now we know what a BPR function is. The next question is, where are all these vehicles coming from and where are they going to? The OD matrix is essentially a table that shows the number of trips between nodes into different networks. Now we have covered the network structure, the BPR function, and the OD matrix. Let's bring everything together to understand how the DTA model actually works. Think of DTA model as a central management system for cities' traffic. And there are 4 steps in the DTA model. These are the following steps. First, you have to calculate the flow, determining the number of cars on each road. Secondly, next is to find the k-shortest path for a second trip. Each trip, meaning that for each trip, the model looks for the fastest routes. Third, distribution of traffic. Allocates traffic across path, avoiding overcapacity. And lastly, it updates the travel times, meaning it processes the 1, 2, 3 steps continuously until the DTA model is stable. Now, we've experimented if the DTA model actually works. And here is how we set it up. We simulated a 6x6 network of roads and intersections. Then we introduced 3 types of flooding conditions: light rain, moderate rain, and severe flood. And in a tool called Sumo, which is a simulation of traffic modeling software, we set up a few flood schedules to test out the DTA model in situations similar to the real-life city. And here's what we observed. As you can see in the graph, every time we ran the DTA model, the traffic time declined. And ultimately, it dropped from 6.87 minutes to 2.66 minutes, which is a 35% drop, which is a dramatic decline in traffic time. As you can see, the DTA model is a game changer for urban traffic management. It efficiently reduces travel time and dynamically adapts to real-time disruptions, including flash flood. Looking ahead, we call this model exponentially scalable, as the model can be scaled to larger networks and integrated with real-world data such as traffic sensors and weather updates. This research is focused on laying the groundwork for future traffic systems that can adapt instantly. Thank you for listening.